To GAK Math Plus. This is your online tutor, George Kemavo. I will take you through series of mathematics topics in the junior high school and the senior high school. I will guide you to understand these topics and apply them in everyday life, and also use them to solve likely examination questions. Today, our focus will be on a lesson in the senior high school. That is the circuit theorem. The circuit theorem is about calculating angles of inscribed figures in a circle. Our objective for this lesson is that you should be able to discover the relationship between angles at the center and the circumference of a circle. You should also be able to apply the theorem individually to calculate missing angles. We have many theorems as far as circuit theorem is concerned, but our focus today will be on theorem number 1. That is the angles subtended at the center of a circle. Let's quickly look at the proof to this theorem. First of all, let's draw a circle with center O, and then let's draw a sector, and from the arcs of the sector, let's subtend an angle on the circumference of the circle. Let's label the vertices of the figure formed as U, V, and W. Let's now label the angles formed at W, U, V, and O as A, B, C, and D. Let's draw a line segment WX through the center O as shown. If you take a closer look at the figure formed in the circle, you will note that we have two triangles formed in here. That is triangle UOW with OX as an extension, and also triangle VOW with OX as an extension. Let's quickly draw these two triangles separately and have a closer look at them. So first we have triangle UOW with OX as an extension. If you take a closer look at the shape formed in the circle, the angle subtended at U is B, and the line OU is the radius of the circle, so also OW is the radius of the circle, and that makes our triangle UOW an isosceles triangle. So the angle subtended at W will also be B. Now, if you take a closer look at the shape, you will note a relationship between the interior angles and the opposite exterior angles of the triangle, and that is the exterior angle is equal to the sum of two opposite interior angles. So we have our angle UOX to be equal to angle OWU plus angle OUW, and that gives us B plus B, which is equal to 2B. Similarly, when we draw our second triangle, we will note that the angle subtended at V is C, and the line OV and OC are equal because they are the radii of the circle. So the triangle VOW is an isosceles triangle, and that gives us the angle subtended at W to be C. Again, falling on the relationship between the interior angles of a triangle and its opposite exterior angle, we can say that angle VOX is equal to angle OWV plus angle OVW. So this gives us C plus C, which is equal to 2C. Now let's put these two triangles back into the circle to see how our new relation will look like. So let's draw our circle with center O, then our shape. Let's label the angle at W and O as A and D. Now let's insert the triangles. We have our first triangle, then our second triangle. If you take a closer look at our new shape, you will note that the angle A is B plus C, and our angle D is 2B plus 2C. Let's factorize this angle to have 2. Then let's open the parentheses on B plus C, and that gives us our angle D to be equal to 2, then the parentheses B plus C. So if we take a closer look at the angle formed at W, that is angle A and angle D, you realize that we have B plus C in angle D, and also we have B plus C in angle A. That gives us a good relationship here between angle A and angle D. So we can say that angle D is 2 times angle A. Or writing this relationship in terms of A, we can say that angle A is half angle D. So what is this relationship telling us here? We can say that the angle and arc of a circle subtended at the center is twice that which it subtends at any point on the remaining part of the circumference. Or we can say that half the angle subtended at the center of the circle is the angle subtended by the same arc on the circumference of the circle. Now, this brings us to the end of the proof. We will look at how to use this theorem to solve questions in our next lesson. You can follow us on Facebook, Twitter, and WhatsApp. Don't forget to like our pages and share these videos when you have them. Looking forward to see you on how to apply this theorem in our next lesson. Thank you.